Hello, and welcome to Kasm's Operations course. In this course, we will cover how to interact with our API, build a custom image, show some tips and tricks around various workspace modifications, and troubleshooting best practices. As an accompaniment to this training video, access to the slides used with speaker notes, and a reference to all commands and configuration settings used in this presentation will allow you to practice the material presented. All slides in this presentation will have links to Kasm online documentation for additional information around the topics being presented. For access to course materials, please consult your Kasm representative. Developer API. In order to get access to Kasm APIs, it's important to create developer API keys. These keys can be created under the Settings Developers menu, and you can add your API key from there. This will generate your API key and API key secret. Other options to choose from on this page are read-only. The read-only setting on the API key overrides permissions defined and is enforced via a separate mechanism. Permissions, however, can be selected after creating an API key. Expiration date is an optional setting to make sure an API key only works for a specific amount of time. Authentication. After clicking Save, you will then be presented with your API key and API key secret. It is important that you save this information, especially the API key secret, as this will be the only time they are presented to you. API key and secret are needed for all requests as JSON data. Two permissions are needed to perform actions as another user with the Dev API. Those are user auth session and user. For our example today, we will also add global admin. All Dev APIs are located under the path API/public. So as an example, https:// the IP or fully qualified domain name of your Kasm server /API/public. We will now demonstrate how to create your API key and to show how to access APIs. But first, a quick peek at our online documentation. In our online documentation around developer APIs, you can see plenty of information around our documented API calls, permissions required to view them, and example requests and responses. For this demonstration, we will focus our efforts around the Get Images API. Let's go ahead and create an API key we will use. First, I'll go to Settings and then Developers, and then I will go ahead and add an API key. I will just go ahead and call this key Operators Course. And I won't worry about selecting read-only or have this token expire. I will go ahead and click Save. And then here we are presented with our key and secret. So it is important to save these, especially the key, because this will be the only time that you will have this information shared. And so I do have a example text file here that I'm going to go ahead and paste this information into so that I have it available. We'll go ahead and close that. We will now select permissions we want to give this key. And so we will use user. We'll add that. We will also add user auth session. And for today's demonstration, we will also add global admin. So while we try and document all APIs that we have, there are some that are not documented. One of the ways that you can get more information about APIs that we have, you can leverage the developers tools in your browser to review the API calls we are making in the UI. So I'm going to go ahead and turn that on. More tools, developer tools, and then let me refresh this page. So as an example, our Get Images API call, you will see here in the Responses tab all of the raw data that is passed as part of this call. What I will do here is to learn more about what command switches can be used on this API, I will right-click on it, select Copy, and copy as curl. I will now paste this in my API's example text file to see the various switches that can be used with the Get Images command. To demonstrate how we might be able to retrieve information from the Get Images command or API call, you will at a minimum need to pass the accept and content type parameters as well as passing your newly created API key and secret to retrieve information from this API call. Luckily, I have these commands queued up in my example text file here, and we'll update these with the key and secret and then run these in our terminal session below. So we'll run this first curl command here, and you will see the raw data is dumped out and is hard to read. So I will go ahead and run this command again, but this time we'll pass it to the JQ command, which will basically do a pretty print of the JSON format. And then here now is more easily readable and is similar to what we were seeing in the developer's tools. Now, how might we use this information from the GetImages API? So now I'll run the curl command again, but this time I will put the results into a file. We'll call it returnedimages.json. Next, I'll use the JQ command to parse through the information and return it into a CSV file so that I can review the image configuration information across multiple images in a table format. I've gone ahead and opened it into Sheets, and here we can see all of the various images that we have loaded in our Kasm installation, the various Docker images tags that we are using, and you can see we have a variety of rolling weekly and base tags. We have one daily, any core or GPU counts across all of them, and so any deviation here, maybe there's an egregious like 200 cores, which we will do an example of later in this presentation. It makes it more easily identifiable so that you may be able to quickly correct any misconfigurations. Next, we will discuss custom images. Building a custom image almost always means taking one of our own Kasm images and modifying it. For our Workspace's core images out on our GitHub site, you can think of the core images basically being like your Alpine, your CentOS, your Ubuntu, but we've stripped everything out of it except the bare bones of what you need to run that image and to be able to run that image within a Kasm environment. Because there are a few variables and a few other settings that need to be in place in order for Kasm to work properly, it is not recommended for you to just take any image and try to shoehorn it into Kasm, because it may not support our interworking pieces like our audio, seamless clipboard, or our ability to upload and download files. Kasm does that work for you and provides our images for our customers to build from. If you create your image from our Workspace's images repository, then all the interworking pieces for Kasm will be in place and will function. 99% of the time, building from our Workspace images repository will achieve what you need without having to fork from our core images. To quickly show what I mean about not needing to build from our Workspace's core images repository, if I go into the Kasm GitHub site, go into Workspace's images and select the Chrome image, you can see that we are building our Chrome image first from our based image of core Ubuntu Focal, and then building upon that from there. Image maintenance. As covered in our online documentation around image maintenance, there are basically 4 steps to follow. First is to build. You will need to create a repository inside of a version control system or VCS, such as a GitLab or Bitbucket, to host your custom image Docker files. You will utilize automated CI/CD toolchains, such as pipelines built into the VCS, or standalone tools such as Jenkins, to automatically build images based on a schedule. We will use GitLab as part of this training course, as it is what we use here at Kasm. Second is to push. Utilize the CI/CD toolchain to push the images to a Docker container registry. This can be a public registry such as Docker Hub, or private registry such as those provided by GitLab, AWS, DigitalOcean, etc. The registry must be accessible by all Kasm agents in order for them to automatically pull those images. Third is to test. Create a new workspace and set the Docker image name, Docker registry, and the Docker registry username and password if authentication is used. Within a few minutes, the agents will pull down the images from the defined registry, assign the image to a testing group, and then verify that the desired functionality you are trying to achieve functions. Fourth is to deploy. When ready, update the user-facing images to use the verified Docker image name and tag. The next time a user creates a session, the new image will be used. A best practice we have is to actually build and test your custom images on a local or non-production Kasm server utilizing our Kasm Community Edition. When performing a build directly on a Kasm server or agent, be sure to disable automatically prune images for the applicable agent. This will ensure that the pruning process won't inadvertently delete unneeded images as part of the build function we are performing. If using Kasm images, most Docker files we provide will have a spot where you can place your customizations. When your customizations are added, you will then build your new image. An example command used to do that is provided here in the bottom of the slide. Now, let's get started in building a custom image. First, we will need to pull down Kasm Workspace images from Kasm's GitHub site. And we'll pull those down to my local Kasm instance that I have here so that we can start to modify one of them. So first we will need to copy the GitHub site repository location. So we'll click on Workspaces Images. We'll go to Code, and then for the HTTPS option, we will go ahead and copy this URL to our clipboard. Next, from my Visual Studio Code application, I've already have a connection established with my Kasm server. I've CD'd into a temp directory, and I will go ahead and pull down those images to this server. We will go ahead and use the command git clone and then the URL that we had copied to our clipboard. And then we are done. You will see over here on the left that we have the Workspace Images folder. All images from the Workspace Images folder has been downloaded. To simplify our view, we're going to go ahead and remove images that we will not be using. And to simplify the ones that we have available to us, we're just going to limit ourselves to Chrome, Chromium, Firefox, and the Ubuntu Focal Desktop. Next, we will want to open the Workspace image that we want to modify. And so the one we want to modify for our demonstration today is the Docker file Kasm Ubuntu Focal Desktop. The first step that we will want to perform here is to change the base tag to the version we are running. As a reminder, it is always best practice to make sure you are lining up your image tags with the version of the Kasm instance that you have. Since we are using Kasm Server version 1.16, we will change the base tag from develop to 1.16.0-rolling-weekly. As for all the other items that are commands that are being run in this Docker file, we can trust that all the install scripts that are present are correct for whichever version we are choosing. In comparison, we go ahead and open up this Chrome one, and we'll open it up to the side. So in comparison, you can look at the Chrome browser and see that it doesn't have nearly as many installations as the Focal Desktop. Chrome is a workspace that only has one specific application to it, as opposed to the Ubuntu desktop with multiple applications. Next, let's pull up our basic build instructions from our online documentation so we can reference the example we will be following. Most of our images will have a customized container here section identified where you can make the updates you are wanting to achieve. Some of our images don't have the customized container here identified, however. If they are not there, it is best to place it after where all environment variables are being defined and before it tries to change ownership of final files. That way, if there's something that's being installed here that is needed as a dependency, like oftentimes Firefox or Chrome will have a dependency for something, then we know that the web browser already exists prior to us doing our custom things. Right now, we are just going to have our custom container create a file called hello.txt, which aligns to our Kasm documentation example. So I will go ahead and copy this syntax into my clipboard, and then we will go back to our Docker file for Kasm Ubuntu Focal Desktop. I'll go ahead and close out the Chrome file. Now, here is an example of where we do not have a customized section to insert this command. So we will go ahead and just insert it right here. Then we need to save the Docker file Kasm Ubuntu Focal Desktop file. Now we want to go back into the Kasm UI and ensure that automatic pruning images are set to off on our Docker agent. So here we will navigate to Infrastructure, Docker Agents. We will select our proxy agent here and click Edit. You will see that we currently have automatically prune images set to aggressive. And so for this exercise, we will go ahead and turn it to off and then click Save. Again, this will ensure that the pruning process won't inadvertently delete unneeded images as part of the build function we are about to perform. From our Visual Studio Code Creator terminal session now, we'll go ahead and change directory into the Workspace Images folder. And then we will want to run our build command to build our custom image. So that is sudo docker build-t. In this example, it was sublime-text:\example-f, and then the Docker file you are referencing. So for us, since we're going to create a hello.txt file, we will go ahead and use this line. Sudo docker build-t hello world:\example-f, and then the Ubuntu Focal Desktop file that we just manipulated. I'll go ahead and put that in my clipboard, paste it, and then run the command. The first time that this command is run, it will take a few minutes to compile. Subsequent build commands run after this first time will go much faster, as all image files will be cached. Okay, the build command has now just finished, and it took approximately a little over 9 minutes. So again, we will make additional modifications later in our example, and the build process from here forward should go rather quickly. All right, up next, let's verify that a local copy of the image we just built exists. So I will go ahead and run the command sudo docker images. And what I am looking for is our hello world example, which happens to be just right at the top. So we have the repository hello world with the tag example. If there are too many images to sort through, you can certainly grep and filter for the results even further. So a command like sudo docker images, and then we will pipe it to the grep command for example, and then just returning the item of interest. Please take note of the size of the compiled image file. So in our example for hello world example, it is approximately 8 gigabytes. Now, let's go to the Kasm Web UI and build our new workspace. So we will go ahead and go to Workspaces, and then Workspaces. And then I will go ahead and click on Add Workspace. For workspace type, we will select Container. For friendly name, we will go ahead and type Hello World. For description, this is going to be we're adding a text file to Ubuntu Focal Image. For thumbnail URL, we will just leave it blank, and it'll thus use the default Kasm icon, or you could find an image that you want to use off the internet. For Docker image, we will go ahead and put hello world, since this is a local copy, with the tag of example. Make sure I spell that correctly. Hello world:\example. We will go ahead and set our cores to 2. We'll use the default memory setting 2768. No GPUs. And again, as mentioned, for our uncompressed image size, we're just going to go ahead and set it to 8 gig. And if I click on the help icon here, the estimated size of a container image in megabytes when extracted to disk. When we define this, the agent can guard against pulling an image if it would result in filling out the disk. So this here is important and able to help the Kasm instance ensure that it doesn't run out of disk space when spinning up new sessions. And then lastly, for CPU allocation method, we will just go ahead and select inherit. We'll go ahead and save the file. We will now go over to our workspace tiles. We will see that we have hello world here as an available option. And let's go ahead and run it and launch session. And we can see here that we have our hello text file on our desktop. Go ahead and delete this session. Now let's go ahead and make subsequent additions in the Customize Container section of our custom image file by adding additional hello.txt files. So we'll go ahead and go back to my Ubuntu Focal Desktop Docker file. I'm just going to go ahead and add 3 more of these so that we have 4 text files. Hello 2, hello 3, and hello 4. We will save our Docker file. And then we will need to rerun our build command. So sudo docker build -t hello world :example -f and then the Ubuntu focal Docker file reference. Go ahead and run it. And then notice this time around how much quicker, roughly 1 second, that it finished building. Now we will go back to our Workspace tiles and verify that we will now have 4 hello text files on the desktop. And there we go. Hello, hello 2, hello 3, and hello 4. Now that we have successfully created a local image, we can go ahead and publish or push our image file. As mentioned, it is recommended to utilize a Docker container registry. In our example, we will utilize a container registry that is provided by GitLab. Authentication to your repository can be achieved in various ways. We will use access tokens for our use case of publishing images to our registry. And so here on my GitLab site, I do have a container registry defined and then access tokens created to help me push images to it and then to be able to pull images down from it. So here, our token name will be used for the username, and then for pushing images up, we need read registry and write registry permissions. The access token key, which I have saved, will be used as the password. And then when we configure our Kasm UI to pull down the image from GitLab, we will use the token name for Docker test token Docker pull, which only has read registry rights, and then the token key for this token will be used as the password. So first we'll go ahead and log into the Docker container registry. And so I have the command here, sudo docker login registry.gitlab-user u for user. And so we were going to do training docker push, and then p, the password and the token key. Login succeeded. And then from here, I could step through and use the same commands to build my image in my registry, but since I have a local copy, I can take a little bit of a shortcut here and just leverage an image tag rename. And so the command to do that, I just did a Google search here for Docker how to retag an image. We'll click on this first link here, and the usage syntax is Docker, the image tag, the source name, and then the target name. And so we have that here, Docker image tag, source name, source image tag, and then the target image tag. And so I already have this command built out here. So we're going to retag the hello world example that we had built, and then now create a tag for our GitLab registry container. In order to see that the new tag exists, again, we will run the sudo docker images tag, or images command. And you will see now that we do have a repository pointing to our GitLab registry and the 116 tag. And then the last step here is to actually push the image. And so we will go ahead here and push our image up. So it's sudo docker push and then to the path in our registry. Now that the image has finished pushing up to our registry, we can go ahead and log out. So that command is sudo docker logout, and then we are going to be logging out of registry gitlab.com. Okay, now our logout is successful. Next, we will update our Workspace object in the Kasm UI. So in the Kasm UI, we will navigate to Workspaces. We will select Hello World workspace that we created earlier, click Edit, and then we will scroll down to the Docker image, and we will now put in our new registry path. And so I will go ahead and grab this, put that in our clipboard, and then paste this here. So we are pointed to our Hello World 116 tag. Next, we will need to scroll down, and in Docker Registry, we will go ahead and put registry.gitlab.com, and then we will use our Docker registry username and token for pulling down the images. Test token -docker pull, and then the token key. And then we can save our configuration. And then next, we can go ahead and launch Hello World again. And as you can see, we are now pulling from our GitLab registry and have the image running. And if we want to see on GitLab our container registry to see if that software has been pushed, the Hello World image, and you can see here the 116 tag has been pushed. Workspace modifications, allowing containers to have root or sudo access. By default, Kasm containers run as a non-privileged user with the UID of 1000. This user can launch programs and perform typical workloads, but cannot install new programs using the System Package Manager. In order to install packages, the Package Manager must be run as root. There are two main methods of running programs inside the container as root: altering the Docker run config to run the whole container as root, or using sudo to run individual commands as root. Please note, packages installed in a running container do not persist when the container is destroyed. To have a package be permanently installed, an admin must build it into a custom workspace. For more details, please see the custom images documentation. And just as a warning, running a container as root is not something we recommend, as it removes one layer of security for preventing a user from breaking out of the container and gaining access to the host system. To demonstrate this, I will start with making a clone of our Ubuntu Jammy workspace. I'll go ahead and update the friendly name to know that we're going to be doing some Docker run overrides. And we'll go ahead and click Save. So now, if I go in and run the Docker run override, it's just a direct clone of Ubuntu Jammy. I'll go in, open the terminal here, and I will go ahead and type the command who am I, and it will show that it's Kasm user. So Kasm user is the generic placeholder or generic name for whichever current user is actually logged in. So now I will do sudo who am I, and you will see that it's prompting for a password, which does not exist. There is no possible password here that we can give. And so if we want to run the entire Docker as root, we can come down to the Docker run config override, which is here. And we just have to add one key parameter, and that is user in root. And just to show that we are following along with our online documentation, click on running as root. We are following along with the examples given in our online documentation. So here we're looking to modify the Docker run config override. I'll just go ahead and copy all this into my clipboard. And then we will update this field. We'll go ahead and click Save, and then we'll relaunch the workspace. Again, we'll type who am I, and now it is showing that we are root, and because we are already root, the sudo command will work as well. Alternatively, we can also modify our Docker exec config, which is right below. And I guess first I'll clean this up to get this back to the default. And for Docker exec config, I scroll down here in our documentation, modifying the Docker exec config field to include the following examples of installing sudo and then configuring sudo to not require a password. So I'll highlight all this, put it in my clipboard, paste it here, and then click Save, and then we'll relaunch the workspace. I'll type who am I, and then now this time you can see it's returning Kasm user, but now I should be able to run sudo and show that we are root. You can also achieve sudo access via file mapping, which I will demonstrate now. And what I'm about to show you here, you could also lean on this to do startup scripts in general, depending on your use case. So I'm going to go ahead and start by cloning Ubuntu Jammy again. And I will update the friendly name to file mapped sudo, and then click save. And then we will go ahead and back in here and edit this, and then go over to file mapping, and then we will add a file. And so for this, we will just go ahead and follow along with our online documentation examples. And we have using file mappings to install and enable sudo. So here in our example, we have the syntax where we can update our file mapping. And the key thing here is we want to make sure that it is writing out to this startup script. So Docker startup Kasm post run post _ run _ root.sh. Get that in my clipboard. I'll go ahead and paste that here. We'll just call this Kasm post run root. For description, sudo applied as part of file mapping. I'll go ahead and copy this code here. Point of note here is that we're going to fill in the details of the file to be mapped, and then we want to make sure that this file is executable when we click save. So I'll go ahead and add that. We'll click executable and then save. Now we'll go ahead and launch this workspace. Now as a file mapped startup script, it'll take just a few seconds for that script to complete. And you can see here we get the message here on the screen, sudo is now installed. So I'll go to my terminal session here, type who am I. So Kasm user is what it's showing, and then sudo should work now as well. So I mentioned that this process here, creating a file mapping to get sudo access, you could also use it to install other applications. So currently, as an example, go ahead and type nc or netcat. You'll see that our desktop here doesn't have netcat installed. So I'll just go ahead and we'll delete this session. Go back to file map sudo and edit it. Go to file mappings. We want to edit this. And then here I'm just going to add a couple of lines to get netcat installed. And so we'll copy that, paste it, and then we'll type netcat here, and then I will update the notify send command to say sudo and netcat are now installed. Go ahead and click save, and then let's rerun that workspace. It's taking a few more seconds longer to run that script because we're getting netcat installed. So I'll just go ahead and open up a terminal session here. Just make sure sudo still works, and it does. Now, if I type netcat or nc, I have netcat available to me as well. Launch forms. So launch forms in the Kasm platform allows our administrators and system integrators the ability to present custom forms to end users when they launch a workspace session. The launch config property defined in a workspace entry is the schema for the form that would be presented to the user when launching a workspace. Once defined, when a user chooses that workspace from the launcher, the custom form will be rendered to the user in order to gather the input that is needed. There are two top-level keys used in the launch config schema. They are file mapping, which will be the location that the user selections will be saved to, and then the launch form itself. So this is where you define the elements or questions you are asking of your users. So some examples here would be if you're trying to connect to a VPN service and you want to tell the workspace what endpoint you want to go to, or if you're trying to pass it a password to connect to an API service, or if you're trying to pass some information to a script for it to do some repetitive action, and how many times you want it to perform that action. Using launch forms can help you achieve these types of workflows by presenting your users with a form to collect that information. Some pretty interesting ways to make use of the launch config form. Lots of different options are available and provides various flexibilities to pass in schema information collected from your users. By default, all of these fields are optional. You can have keys, labels, values, placeholders, or choose whether a field is required or not. You can hide fields so that they are not visible until something else is selected. You can force the input type to be a text or to be a password so that you can't see what's being input on the screen, or verify that the input is a number or fits some type of description by using your regular expression validator. This is a really nice way to make what could potentially be a complicated workflow for your users and streamline it to make it easy for them to just launch a workspace, select a couple of options, and then they click a go. So in this example, I'll go ahead and show you how to create a launch form and to gather user input when launching a workspace. But first, as mentioned in the other examples, we will be following along against the online example. So we'll go to search for launch forms, workspace launch forms. Again, we're going to be updating the launch config JSON parameter. And so for our launch config schema, again, file mapping and launch form are the two items we need to pass. We have a couple of examples here. The file mapping, what the destination is, and then the launch form itself. And so we'll go ahead and do that now. We'll go ahead and clone Ubuntu Jammy again. And for our friendly name here, I'm going to just call this launch form, and then we'll hit save. Go back in here and edit it. And then we will scroll down to the launch config JSON here. And then I'll copy in those examples and paste it here. So you will see here I've combined the file mappings entry and then the launch form itself. Go ahead and click save, and then let's launch that workspace. So here you will see now that we are presented with a VPN service option. We have Tailscale, OpenVPN. So I'll just go ahead and select Tailscale. And then it wants us to pass whatever the authentication key is. And so I'll just put some random letters in here to collect that. And then we will go ahead and launch session. And so just to show that we're passing these parameters into your workspace, we can go ahead and just show the results of that JSON file. So temp launch selections.json. And then you can see there that we selected Tailscale, and then the random characters I had typed into the Tailscale key. Our Kasm VNC DLP settings allow you for more granular controls outside of all the out of the box control panel settings that we have covered previously. So you'll be able to control, as an example, like what's visible on the screen, so what parts of the screen they can actually view. You can apply watermarks across the entire screen. More granular control over your clipboard, so only allow clipboard to pass text, but not allow it to do any images or files. And then as well as setting default language to something specific that you want. The Kasm VNC configuration file location is located in /etc/kasmvnc/kasmvnc.yaml. And this file is something that you can manage with our file mapping feature. For full reference on all of the various Kasm VNC YAML configurations, please see our online documentation. So we'll now demonstrate using file mappings to define Kasm VNC DLP policies. But first, let's just go ahead and check in our online documentation to show the example we will be following. So let's see here, DLP policies, and applying Kasm VNC DLP policies. So again, we're going to be managing a file that we will place in the etc Kasm VNC YAML. So let me just go ahead and copy this to my clipboard now. And then more specifically, we're going to be copying this example here. So I just wanted to highlight here at the top where we're passing in a PEM certificate and PEM key. as part of the network parameter. And so an important note here that the network portion of the configuration shown, this actual piece is actually required, as those settings here will override the Kasm VNC defaults, which are required for it to operate within the Kasm Workspaces. And then you can see here the destination path is what I just entered in my clipboard. We'll go ahead and we'll go to Workspaces, and we will go ahead and clone Ubuntu Jammy yet again. And for a friendly name, we will go ahead and call this Kasm DLP, and then we'll hit save. Let's go ahead and edit that again. We'll go to File Mappings, and then we'll go ahead and add a file mapping. The destination path that I had saved. For name, we'll call this Kasm VNC configuration, and we're going to apply a DLP settings. And then let me go ahead and copy stuff to my clipboard and then paste it here. So again, these are required, your PEM certificate and PEM key. And then for data loss prevention, I did make one modification here, and that was I'm extending from the left portion of the visible screen out 60 spaces just to move it over a little bit more. But everything else is the same. And then I excluded the watermark in the example because I don't necessarily have an image file to upload as part of this exercise. We'll go ahead and click Save Now, and then we'll go ahead and launch that workspace. So this DLP control was to define our visible area. And so you can see here now that the region starts roughly 10 pixels down. We're 60 pixels over from the left, and so it's impeding upon our icons here on the left side of our desktop. It's 40 pixels from the bottom and 40 pixels from the right side of the screen. Up next is troubleshooting. So Kasm Support is only available for our professional and enterprise customers who have purchased a support contract. To open a ticket, we ask that you please fill out our form located at kasmweb.com/support. When filling out our form, make sure to fill out all the fields are populated, and please ensure that you have your correct Kasm Workspace version that you are running and your support level subscription. Also, always helpful to include any screenshots, videos, or log files that contain the errors that you have observed. Up first, we want to highlight the existence of a static login page for administrators to use in cases where they have SSO enabled and auto login configured. So when you have one of these configured, it's good to know that this web link exists in order to be able to pass local login credentials, especially for local administrators. So to simulate this, I will set up a symbolic link, so to speak, to simulate an SSO configuration with auto login enabled. To set up a symbolic SSO configuration, we're going to go ahead and navigate to Access Management, Authentication, and then SAML. And then we'll go ahead and click Add Configuration. For display name, I'm just going to call it Sample SSO. For host name, we will want to point it to the IP address of your Kasm server. So I'll go ahead and copy that. And then most customers, when they have this configured, will go ahead and enable automatic login. So just pass you through straight to your identity provider. For entity ID, we will simply type placeholder here. For the single sign-on service or the SAML 2.0 endpoint, here's this symbolic link piece that I was referring to. And so we're just going to essentially have a redirect to the Kasm website. It's www.kasmweb.com. And then for the X509 certificate, again, we will just type placeholder and then click Save. So now that we have this in place, you'll see here, it has already sent me here to the static login page. But I now have this sample SSO button configured. And if I were to click this, it'll do the redirect for me, and then in this case, it's sending me over to the Kasm website. So let me go back. For your regular users, however, you will have them, you typically give them the /pound/login as their web link to use to log in, or just simply your host name of the box or IP address of your Kasm instance. We would just go ahead and leave /pound/login for this. And then I will go ahead and click refresh. And then you can see here, it did the auto redirect or auto login to simulate that. So to get back to the static page, I'll just go ahead and paste this path in, /pound/static login. And then we're back. And then I can go ahead and log in with my local credentials. And I'll go ahead now and remove this configuration. So the next thing I want to show you is how to troubleshoot images, right, and review your logs. And so to do that, we need to actually simulate some errors. So the first one here, I want to show how to simulate an image that can't be found. So let's go ahead and go back to our workspaces. And I'm going to select Chrome this time, and I'm going to clone Chrome. And we'll just call this invalid Docker image for friendly name. And then we're going to go down to the Docker image path here. And you can see, it's the one that we had installed, the 116.0-rolling-weekly. And then I'm just going to add a couple miscellaneous characters on the end of this path. So just adding a couple of X's there, and then I'm going to go ahead and click Save. So to troubleshoot, we can see here that this cloned image, right? It has the triangle. The image has not been detected on an agent, and it may still be downloading. We can see that our Chrome image, not been added yet because of the orange triangle. And normally, right, it would take approximately 5 or 10 minutes so on average, to download any new image, right? And Kasm agents will check every hour, right, and try to re-download any image if it sees an update is available. So if we see that pulling this image takes longer than, say, 10 minutes, that might be a good indication that there's a mistake somewhere. So we'll let it accumulate a few more errors, and so that we can review later. We should tell us if Kasm cannot pull the Docker image. So we'll go back in the admin console here, and I want to go ahead and generate another error where there are no resources available when we launch a new workspace. So we'll go back to Workspaces, and here we will go ahead and and clone Firefox. And for our friendly name, we'll just say no resources available. And then for this one, let's say we'll go over here to our CPU cores, and let's say it gets fat fingered, and we say we want 200 cores to launch this workspace. So I'll go ahead and click Save, and then we'll go ahead and go back to our workspaces. We have our Firefox browser, no resources available. We can still see here our invalid Docker image still has the orange triangle there on that icon. But let's go ahead and launch this Firefox session. We'll click Launch Session. You can see here right away, no resources were available banner was displayed. So, what this means is that, Kasm has no way of providing the resources necessary for this workspace, right? And it doesn't have a way to auto scale enough to reach the necessary amount for this workspace. So, in addition to that, another reason that you could possibly get this error is if Kasm at some point maybe had the image for this workspace, but then lost the image, like someone maybe SSH'd into a machine and they manually deleted off the Docker image for it. And Kasm is not aware that that image doesn't exist. So it, in that case, right, it would try to launch the workspace, assuming that the image is there. And then when it tries to load it, it gets a no resources available. And so no resources available could be, like a generic error in that sense, right? That describes the resources in the workspace configuration, right? And that there's a mismatch where the resources needed are not available, whether that be CPU cores, like what we did here by setting it to 200. Not enough memory, not enough GPU, or just not simply having the image fully available to launch. So we'll go ahead and close this out, and then we'll go back to our dashboard. So we can go ahead and see what are in our error logs. So on our dashboard, you will see here that we have a widget for our errors and with a count of the current errors that have occurred over the last 24 hours. So by clicking on this widget, it'll send me over to the logging section and then display the error logs. Conversely, I could, starting from the dashboard, from the admin console, if I didn't necessarily click on this widget here, I could go to diagnostics and then logging, and then by default, Kasm logging will show you the last 60 minutes of logs. And so what might be more helpful, right, is to change this to a full day. And so we would increase this to 1,440 minutes, which is a full day. And then if we change our filter here for error, it'll focus in on the errors that have just been generated. There are more filter buttons here that you can use if you want to zero in on a certain application or host or message. These are available, and so we want to find the errors associated with the things that we generated. And so we'll look at this first one here, and we can see, right, failed to pull the image because in this case it doesn't exist, right? And we can see that we put this in here, rolling weekly XX. But say you didn't know that, right? And so you would want to go ahead and head out to your repository where you're pulling this. In our case here, it's Docker Hub. Go to Kasm Docker Hub, and this was our Chrome image. Go over to tags. It was 1.16, and so 1.16. Rolling weekly, maybe copy that to your clipboard, right? And then compare it to your error message, right? And then maybe that makes it easily identifiable for you. In addition, it was a 404 error that was generated, and 404 in and of itself is an indicator that it couldn't find something. And then we can go ahead and scroll down, and we want to find, there it is. And so here was our no resources available error. In this case, right, it's saying, no resources are available, no agent slots are available, which tells you that either your agent resources are too small or your workspace configuration is set too large. And so in this case, we set the cores too high at 200, right? It'll never be able to spin that image up. When contacting support, right, it is very common that we may ask you, to come out to logging, set your error and filter and time limits, right, to, maybe a full day or the time or a larger amount of time, so we can capture as much as possible. And then what we'll have you do is we'll have you hit the export button here. And then what this will do is export everything in the current filter of what we have on the screen, right, and download it into a JSON file. And now that you have this file, right, this is something that you can upload when you are working with us here in support, right? And then once you reply with this file, right, we'll be able to see all the same error messages, and this will help us greatly to do triage for you. And so let me just open this one up. And so our application export JSON file, right, has all of this logging information in it, right? And so it can be super helpful for us when helping troubleshoot and do triage. I'm just going to go back in here and we're going to delete those last ones so we don't generate any more errors, or I'll leave this one. I need to fix that invalid image one. I want to go ahead and delete that one so it'll stop generating errors. Another thing that support will often ask you for is to export a HAR file from the Developers tab. Let's go ahead and turn that on for my Chrome browser here. More tools, developer tools. And then on the network tab of the developer tools. And so when using the developers tab, it's always best when launching your workspace, and we'll go to Chrome here, launching it into the current tab so that your developer tools can capture the events that are occurring. So in this case, I'm just going to leave it on New tab, Launch Session. It sends me over into a new tab. It launches my Chrome container, or Chrome Workspace, and I no longer have Developers tab running to capture any events that is occurring. And so here, it was making the request to start that Chrome session and then launch it into a new tab. We're going to go ahead and launch the no resources available because we know that one generates an error. And just let me go ahead and clear out those log files. And so, always select current tab, click the launch session, it generates the error, and then there we have it here, that error message is here. And so we will ask you to download your HAR file. To do that, you will click this button here, Export HAR. And then we'll go ahead and save that file. I had saved this before. We'll just go ahead and replace it. And then you can upload that file to your trouble ticket. And then when you attach that HAR file to your case logs, it gives us the ability to review it. And so subsequently, we could just import that and then troubleshoot from there. Go ahead and close this. We'll stop that. And since we have Chrome open over here, sometimes, right, you will have users who are experiencing poor performance, and a lot of times we don't think about Google Chrome, or web browsers as being processor intensive, right? But having multiple tabs open can eat up a bunch of RAM, and JavaScript can eat up a lot of compute. So if your users are describing their issues when they're on a Teams call or some sort of remote call while using their workspace, it can consume a lot of resource. This can make it hard sometimes to know, where the latency is coming from. Is it coming from my network? Is it coming from Kasm? Is it coming from the end user's computer? And so one way that can help you with troubleshooting is our streaming quality item over here in the control panel. So one of the things you can do or try is to change the streaming quality of the workspace. And so you have the option to select low, right, which will be very bandwidth conservative. I can select high, right, it's going to be more bandwidth intensive, right? I can select extreme, which is not necessarily recommended for anything outside if you have a direct hardline connection to said workspace, or I could select even static, right? So maybe this is just good for reading things like static text. We have max FPS, and so when selecting this value, it doesn't mean that they will necessarily get the value set. And so let's say we set this down to 19. What this means is that the maximum FPS that they would achieve would be 19. Right? This can be used to help control bandwidth, not a way to ensure high fidelity. But if they're going to be running an application that needs high fidelity, right, then you would encourage them to set the quality to high, and then they can also increase their FPS. And so this will eat through a lot of bandwidth, so make sure both their connection and the client computer they are using are capable of handling it. You will get metrics around CPU usage and network here, now displayed on the Kasm Workspace in the upper right-hand corner. So to demo this, let's And so here you'll see, it's a video streams, you can watch the performance stats output. This is a way to help you troubleshoot, or help your users to control their streaming quality. In addition, right, as administrators, this can also help with troubleshooting if users are experiencing, say, mouse or keyboard latency. And then we can even increase the max FPS. We'll put it back to 24. And then that should start to go up. And there it goes. Okay, we'll go ahead and delete this session. Another capability that you have to help troubleshoot is that you can actually start an image in standalone mode, right, and then try to access it through a web browser. This technique can also assist you in troubleshooting images that don't start. So we'll go back to our Docker Hub website, and I want to look for the Ubuntu Focal Desktop. This one here. And all of our images here will have information around standalone deployment, right? So the image was designed so it can run natively within the Kasm Workspaces, but it can also be deployed in standalone, right? And then accessed through a web browser. And so here's the command that you could run to do that. And you will see here that it's only going to be accessible via port 6901. So we would point our browser at the IP address of the server, port 6901. You will be prompted for credentials if you choose to run it in standalone mode, and these are the credentials that you would use. Please note that, again, some functionality, audio, uploads, downloads, microphone, right? Those are only available when using Kasm Workspaces for orchestration. So we're going to copy this to my clipboard. We'll go over to my terminal session, and then we'll paste that in, and let's go ahead and run it. And so it's going to go ahead and pull down this image, and so we will wait for that to complete. So as the Docker image starts, you can review the information on the screen for error messages. This is a great way to help do troubleshooting, because if for some reason something that you've added to your Docker file is preventing the image from running correctly, you'll be able to see it in these Docker log output here and be able to see or diagnose where exactly it is failing. Now in this case, I assure you that all of the warning messages and stuff that are showing here aren't perfectly normal. Okay, and so we'll go ahead and log in. Put in the IP address of the server and port 6901. And so we're getting the self-signed certificate warning. And then we'll be prompted for credentials. So remember, on our login page, the user is Kasm user, password is password. So Kasm_user, password is password. And we are able to sign in. And then I can interact with this Kasm container the same as anything else. To stop this session, all we have to do is hit Control-C. So additionally, we can take that same command and we can modify it. So let me copy this to my clipboard. I will paste it up here. And we can put in the custom image that we built earlier in this course. So let me just paste this here. And we can run that. And then I can go back to my browser, put in the IP address and port number. And at this point, my credentials are cached from the last one that we ran, but I'm able to authenticate in, and you can see it has those hello text files that we had created as part of this image. Troubleshooting failed containers. So showing you how to run a Docker image in standalone mode, gave you the ability to review the Docker logs directly. So now I'll demonstrate next how you can do that when launching Workspaces via the Kasm console. But first, what we need to do is turn off our removed failed containers setting, which is located in our agent app config.yaml file, by setting it to false. That way, it'll allow us to review the Docker logs directly without worrying about Kasm going in and cleaning it up. As mentioned, we do have a KB article which describes how to accomplish this, and I will follow along in the steps here to do this. So to ensure that we don't delete failed images so that we can review Docker logs, let's go ahead here and we'll just go ahead and do a cat current conf app agent app config.yaml file, and inside of the contents of this file is right here. So remove failed containers is true. So we want to go ahead and turn that off and set that to false. So our first step is to go ahead and stop our Kasm services, and so that command will be sudo opt kasm bin and stop. And then let's go ahead and modify the agent app config. And then let's go ahead and start our services. And now from this moment on, our agent won't clean up any containers. And now since it's not going to delete it, we'll be able to review Docker logs for any specific container that we are troubleshooting. So let's go ahead and create a condition where a Docker container will fail to launch. So we'll go ahead and go into admin. Go to Workspaces, and we'll go to Ubuntu Jammy, and let's clone it one last time here. For a friendly name, we will call it fail at launch. Let's go ahead and save that. And then we'll go to fail at launch. Let's edit it, and I'll add a file mapping. For this file mapping, I'm going to name it bash rc. Bash rc, and then for destination path, I'm going to put it at the home Kasm user, and bash rc home Kasm user bash rc. And then for our text field, I am simply going to type invalid. So this file is often used to customize behavior when you open a shell or terminal to a Linux system. And because of how our Kasm default profile check works, placing it directly into the home Kasm user location will actually cause this to fail. The correct path, if trying to do this, should be /home/kasm-default-profile and then /.bashrc instead. So we'll go ahead and save this. And then now we'll go ahead and run the failed at launch workspace. And an unexpected occur creating the Kasm. Error message is displayed. And then now we can go ahead and go over to our terminal session. In order to see what sessions are running, we will go ahead and run the sudo docker ps-a command. And then here, right at the top, we can see the Ubuntu Jammy session that we just tried to start. And so what I will do is just we'll double click here on container ID and put that into my clipboard. And then to review the Docker logs directly, we can run the following command: sudo docker logs-f, and then we'll paste in the container ID. Now, again, because of how our Kasm default profile check works, placing it, into the home/Kasm user location, will cause this to fail. And so then we can see here inside the Docker logs, this sequence of events in several places. So this is the path that we were trying to put the bash rc file, right? And then saying, our profile already exists, will not copy it to vault containers. And so we see that in several locations in this file. This concludes the operations training course. As a reminder, as an accompaniment to this training video, access to the slides used with speaker notes and reference to all commands and configuration settings used in this presentation will allow you to practice the material presented. All slides in this presentation will have links to Kasm online documentation for additional information around the topics being presented. For access to course materials, please consult your Kasm representative.